Okay, question on number 42 in the multiple choice packet, and totally fair question because I didn't show much work on the packet compared to what I actually did. So let's take a look at what this means. There's also a different way of describing the rectangles. They use the word inscribed rather than saying left or right rectangles. So the first thing I'm going to do with any of these is try to picture it. When I'm trying to use trapezoid or any of my rectangle rules, I like to picture what's happening. So I would assume this is a calculator question because there are decimal answers. So if you're wondering about that, go ahead and grab your calculator and plug in e to the x squared. I also would guess that we could probably do, in our head, figure out e to the x is, remember, goes like this. And if I'm going to make that e to the x squared, your x's are just increasing faster, but it's still going to be the general shape. It's just going to be a steeper curve. Okay, now, interestingly, the left-hand side, when you go to the negative x values across your y-axis, it does actually change, and it becomes, rather than going down, it becomes a positive curve like this. So that's a little bit interesting, but this we're only dealing with positive values from 0 to 2. But while you're graphing it, maybe think about why that happens and if that makes sense to you. Okay, so I got my basic shape in my graph, and I need to approximate it 2 different ways and then find the difference. So sneaky, they're trying to make you do twice the work here rather than just do trapezoids or rectangles. They're saying do both and then find the difference between the two. So just good to note. Maybe circle that so that we remember to come back and answer the question at the end and don't think that we're done when we get halfway done. It says 2 inscribed rectangles of equal width. So I'm going from 0 to 2. And the first thing they say is inscribed rectangles. So I'm just going to draw on my height so I can try to picture my rectangles here. And usually we refer to them as left and right rectangles. So here's the deal. If I go left rectangles, I take my left-hand height, and then I take my left-hand height again, and I have those 2 rectangles. Those are under my curve. We might call it under approximation. Inscribed is really another way of referring to that under approximation. If you go back to, I'm trying to think of when else we use that word. We use that word in the circle chapter in geometry, and an inscribed angle is something where your angle is inside of your curve. You don't go outside of it. So I guess it's that same kind of idea. If we were to look at right-hand rectangles here, right-hand rectangles would be what I'm putting in yellow there, and those go outside of my curve. They're not strictly under it, so I'm not sure what we would call those, what the opposite of inscribed is, but they wouldn't be inscribed. So that being said, let's go ahead and stick with our inscribed rectangles. So how am I going to find the area of those rectangles that I've sketched in green? Well, I've got 2 of them, so I'm going to go with width times height, or base times height. Height being the difference in my x values, so from 1 to 0. And then my height, my first one is times f of 0. And then my second one is going to be a width of 2 minus 1 times f of the height is at my x equals 1. So that's kind of a general setup for you. You're probably thinking, well, of course the width is just 1, yes. And when I plug in a 0 into my function here, which is e to the x squared, e to the 0 squared is still 0, which means it's 1. So that actually just ends up being 1. You could, of course, go to your calculator. Sometimes I find we make more calculator errors, so if I can do a little bit in my head, I do. And e to the, when I plug in 1, I get 1 squared, which is just 1. So my first rectangle literally has an area of 1 here, and then the second one has an area of 1 times e to the first, which is e to the first. So my area ends up being 1, my total area, 1 plus e to the first. Type that in your calculator, and you get 3.718 for the approximation using inscribed rectangles. Now, the second thing I need to do is I need to go and find the trapezoidal approximation. So trapezoidal approximation from 0 to 2. So trapezoids, remember I'm connecting here and connecting there. So again, one at a time. This time I'm thinking my bases of my trapezoids are actually my heights, and my height is actually the width here. So my general formula that I think of for trapezoids is base 1 plus base 2 divided by 2 times height. So that's going to look like this. That's going to look like f of 0 plus f of 1 divided by 2 times a height of 1 minus 0. And then f of 1 plus f of 2 divided by 2 times 2 minus 1. Okay, hopefully you can follow where that is coming from. I got to do a little math here, so I'm going to do a little simplification first. So again, this is e to the 0 plus e to the first squared, which is e to the first, divided by 2 times 1, plus e to the 1 squared plus e to the 2 squared is 4, divided by 2, and then times 1 again. And it's up to you. You can go ahead and say this is 1. You can grab your calculator at this point because we are going to need our calculator. And let's just do a quick double check. 1 plus e. Make sure you're using parentheses here, doing the numerator, then dividing by 2. And I'm getting 1.859. And crazy, but the second one is 28.658. Much, much, much bigger. Remember, it's increasing exponentially, and my graph doesn't really do it justice for what it actually looks like. So my total area here, my total approximation is 30.517. Just wanted to do a quick double check that that's what I'm getting. Yep, 30.517. And now I'm going back to the actual question. Remember, I made you circle, underline this at the beginning, the difference between the two. So I'm taking the difference between 30.517 and 3.718. And that's giving me 26.799 or 26.80 when I'm rounding to 2 decimal places, which is weird that they're doing 2 decimal places because I know I told you normally 3, but hey, that's what the question is doing this time. So 26.80 is my answer. Hopefully that helps. That's a good review of a couple skills there because we need to be able to do trapezoids and do rectangles as well. And maybe the wording was just what threw you off there.